Your container exits with import error, libsl, so 1.1, cannot open shared object file. No code changed in 3 weeks. The root cause, your Docker file used from Python 3.12 Slim without pinning the OS codename, and the official image silently swapped Debian 11 for Debian 12, dropping the library your database driver needs. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Docker images containers. A Docker image is like a recipe card. It describes exactly what ingredients and steps are needed to produce a dish. A container is the actual dish made from that recipe. Images are immutable. Containers add a thin, writable layer on top. Images use UnionFS to stack layers. Each Dockerfile instruction creates a new layer. Containers share the host kernel but get isolated namespaces. Use images to distribute your app, use containers to run it. A Dockerfile is a recipe for building an image. Each instruction creates a new layer. Docker caches layers and only rebuilds from the first changed instruction downward. This is the single most important optimization for build speed. Here's a best practices Dockerfile. Notice we copy requirements, txt first to leverage layer caching. Then we install dependencies, copy the rest of the code, create a non-root user, and set the command. A container is a running instance of an image. The lifecycle includes create, start, stop, and remove. Port mapping forwards host ports to container ports. Always bind your app to 0000, not 127001. Here are common Docker commands. Use Docker run with D for detached mode, P for port mapping, E for environment variables, and RM to auto-remove on stop. Docker stop sends SIGTERM for graceful shutdown. Containers are ephemeral. For persistent data, use named volumes. For development, use bind mounts for hot reload. Containers on the same Docker network can reach each other by container name. Never use localhost for container-to-container communication. Here's how to use named volumes and custom networks. The API container can reach the DB container by the hostname DB. Named volumes persist data even after container removal. Multi-stage builds let you compile in one stage and copy only the binary into the final image. The result is a tiny, secure image with zero build time cruft. This is mandatory for production. This Go example uses 2 stages. The builder stage compiles the binary. The runtime stage starts from a minimal Alpine image and copies only the binary. The final image is 18.4 MB instead of 1.2 GB. Without limits, a single container can consume all host resources and starve others. Always pin CPU and memory. Docker's default is unlimited, don't trust it. This compose file sets hard memory and CPU limits for each service. The web app gets 512 MB and 1.5 CPU cores. Redis gets 128 MB and 0.5 cores. Test with Docker stats. This is the same issue we highlighted at the start. Here's exactly why that happened. The Docker file used from Python 3.12 Slim without pinning the OS codename. Between builds, the official image updated from Debian 11 to Debian 12. Debian 12 ships libsl 3, not libsl. The scicop2 binary package compiled against libsl 1 could not load, causing the import error. The fix was simple: pin to an exact version and OS codename. We changed from Python 3.12 Slim to from Python 3.12 3 Slim bookworm. We also added a CI step to log the base image digest and fail if it changes unexpectedly. This prevents silent upstream changes from breaking production. If you copy all files before installing dependencies, any code change invalidates the pip install layer, forcing a full reinstall. Always copy requirements, txt first. This is the exact line that caused the production incident. Python 3.12 Slim is a moving target. Always pin both the version and the OS codename, e.g. Python 3.12 3 Slim bookworm. A single stage Go image can be 800 MB or more, shipping the entire SDK and source code. Always use multi-stage builds to ship only what's needed. Inside a container, 127001 is the container's own loopback, not the host's. If your app binds to 127.0.0.1, it only accepts connections from within the container, making port mapping useless. Always bind to 0.0.0.0. Bind mounts couple the container to a specific host path. If the server is replaced, the data is left behind. Use named volumes for production persistence. They are portable and managed by Docker. The article uses Docker Compose, V1 syntax in some examples, but Docker has deprecated V1 in favor of Docker Compose, V2 with a space. Ensure your Docker engine is up to date and use Docker Compose commands to avoid deprecation warnings. The article mentions pinning to a digest but doesn't show the syntax. Use from Python 3, 12 slim at SHA-256, ABC 123 to lock the exact image. Obtain the digest via Docker pull and Docker inspect. The article covers resource limits but omits health checks. In production, always define a HELTHCHCK in your Dockerfile or Compose file so orchestrators, like Docker Swarm or Kubernetes, know when a container is truly ready. Without it, traffic may be routed to a container that hasn't finished initializing. When a container fails, start with Docker logs. If the app is unreachable, check port mapping with Docker port. To compare base images, use Docker inspect to get the image digest and architecture. Let's run through some common interview questions. What is the difference between an image and a container? Image is a read-only template. Container is a running instance with a writable layer. How do you reduce Docker image size? Use slim base images, multi-stage builds, combine run commands, and use Docker ignore. What does exit code 137 mean? Container was killed by SIGKILL, typically OOM. Check memory limits. And a few frequently asked questions. What is the difference between ENTRYPOINT and CMD? ENTRYPOINT sets the executable, CMD provides default arguments. How do I reduce Docker image size? Use slim base images, multi-stage builds, combine run commands, and use Docker ignore. Does expose publish the port? No, it's documentation only. Use P to publish. To recap, images are immutable blueprints. Containers are ephemeral instances. Always pin your base image tags, use multi-stage builds, set resource limits, and bind to 0.0.0.0. These practices will save you from production outages. Ready to go deeper? Up next, Dockerfile explained, then Docker volumes and networking, then Docker Compose. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.